Deck of 18 custom playing cards is numbered from 1 to 18. Card is drawn 6 times with replacement. If X is the number of draws that result in a prime number, what's the expected value of X? So we are given a deck of cards. There are 18 cards in the deck numbered from 1 to 3 up till 18. And we are drawing cards from this deck one by one with replacement. So we draw one card and then we put it back. And then we draw another card again and then we put it back. This is done 6 times. Now, when we draw the card, it could be a prime or it could be a non-prime number, and we are told that X is the number of draws that result in prime. So what's the expected value of X? So let's go ahead and see how we solve this. The first step is to identify the prime numbers. Because this is a small range 1 to 18, we don't really need this Python code. We can simply count the numbers. So there are 7 primes: 2, 3, 5, 7, 11, 13, and 17. Out of 18, we have 7 primes. So now we can say that the probability that a given single draw gives us a prime is 7 out of 18. Next thing we'll do is we define a random variable. Let xi be an indicator variable for the ith draw, where xi is 1 if the ith draw is a prime, and it's 0 if it's not a prime. So now we can say that the total number of primes in all the 6 draws would be the sum of all of these xi's, so x1 plus x2 plus up till x6. Let's say x1 was not a prime, so this would be 0, plus let's say x2 was a prime, this would be 1 plus, and so on. So the total number of primes in 6 draws is the sum of all of these indicator variables, summation of xi, where I goes from 1 up to 6. Now we can compute the expected value. So expected value of x would be the sum of expected value of all of these xi's. This comes from the linearity of expectation. Now, since xi is Bernoulli, so indicator variables is the same as a Bernoulli random variable, where the random variable can take two values, either 1 or 0, 1 with certain probability p and 0 with probability 1 minus p. In this case, for the case of a prime, we already estimated that the probability p was 7 out of 18, because we have 7 primes out of the deck of 18 cards, which are numbered from 1 to 18. So each xi is Bernoulli with probability p equals to 7 divided by 18. So we also know that for a Bernoulli random variable, the expected value of the variable is equal to p. So expected value of each of xi would be p, which means that the expected value of x would be p times 6, because we have 6 of these. So this gives us expected value of x is 6 times 7 by 18, which is 7 divided by 3. So this is the answer to the question. So a simple and straightforward question which tests your understanding of a few different concepts. The first one being the linearity of expectation, that is, the expected value of a sum is the sum of expected values regardless of independence. Indicator variables, Bernoulli trials, each draw is independent and has 2 outcomes, prime or not. So that's the answer to the question. Thanks for watching, and I'll see you in the next video.